want to talk about the full adder logic circuit. Now the full adder adds 3 bits together. One of those is going to be the carry bit. It's made up of AND, XOR and OR gate, and you can see in that, if you look at the red rectangles there, you can see that it's actually made up of 2 half adders. The output then includes the sum and the carry bit, so it outputs 2 bits, the sum value and the carry value. Let's have a look at the full adder in operation. Let's apply now some bits to the full adder to see how this works. So we're saying now that our input for A is 0, our input for B is 1, and our input for C is 1. Now putting those values in, if we go through this XOR gate at the top here, we've got a 0 and a 1 as our inputs, therefore our outputs for that is going to be 1, so that's going to be 1D. And then if we've got an input of 1 at C and we've got 1 at D, we've got 2 1s going into our second XOR gate here, then 2 1s going in the XOR gate, so we're going to have a 0. So our value at S here, S output there is going to be 0, so our sum is 0. Now for the other side, for the C value, now we need to work out what's going on there. So we've got the D value for D, which is going into our AND gate here, and we've got the value of C, which is 1. So we've got 2 1s going into our AND gate in the middle, and therefore our output to that at E is going to be 1. And for our bottom AND gate, we've got a 0 going in, we've got a 1 going in, therefore we are going to have 0 as an output. So there's a 0 at F. So going into our OR gate at the very end there, we've got a 1 for E, a 0 for F. Well, going through an OR gate, the output of that is going to be 1. So our output for our carry is going to be 1. What we can do is we can take a full adder and create a binary adder by putting them into a sequence. You can see in the example here we have an adder which is inside this red rectangle here, and we've chained them together. So the output of one binary adder becomes the input of another, and we can chain them together in this way. This allows us to add up binary numbers with any number of bits. So in this example what we're doing is adding 2 numbers with 3 bits each. So what we're saying is, if you look on our right hand most column here, so if you imagine this being our least significant bit here, so you've got A, A1 and B1 and C1, so adding those 3 values there, so those essentially are inputs here into our first adder. And then we work all that through the circuit, and we end up with a value for sum, and we end up with also a carry value. But that carry value then goes into the C value the carry that goes into our next adder. And then we can work out the values that come out of that, and then those values then, the C value for that goes into the carry value for that goes into the next full adder. So by chaining them together, what we're able to do is we're able to add up values that have different number of bits. Let's demonstrate how this binary adder works by applying it to 2 3-bit numbers. So the 2 numbers we're going to add in this case are 101 and 011. So to start with, on the values that go in on the left hand side of the binary adder here, the 2 1s are the rightmost values, the 2 1s on the rightmost value of our binary addition problem we're trying to solve here. So we've got the 2 1s here, they go as an input as there. We also have the 0 going in at this point. Our carry is 0 at this stage because it's the right handmost bit, our least significant bit, so we're adding those together. So then we put those values through our full adder, and out comes, in this example here, out comes a 1 for our carry bit and a 0 for our sum. So we add that to our answer there. So we're putting 0 down and adding 1 as the carry, and then we're now putting our values that are going into our second adder here. they are now the middle 0 and 1. So those values go in. So now inputting into that, we've got 0, 1, 1, 1. And again, we put that through the full adder, and out again we get another set of values. So again, our next sum value is 0, our carry value is also 1 here, and then we put our rightmost values of our problem here, the 1 and the 0, put those into our final full adder, put those values through, and we get out 0 and 1. And therefore you can see how these adders, when we put them all together, chain them up all together, we're able to add up values with multiple bits in them, not just a single bit as we can with a half adder, but we can do it with multiple bits. And we can extend our binary adder to add up any number of bits. This is a 4-bit binary adder. What we've done now is we've taken the full adder and effectively put that into a black box inside each of these rectangles here, so you can demonstrate and we can see this more clearly what's going on there, especially when we're concerned with the inputs and how the values are passing from one full adder into the next full adder. So you can see, starting on the right hand side of the diagram here, and also matching the right hand side of our expression here with the least significant bits. So we've got A0, B0, C0, so those are values that go in here into our first full adder. Out from that gets returned the sum, or S0 in this case, but then the carry value then gets forwarded on to the next full adder, and that happens all the way through the sequence until we've added up all the bits in our binary numbers.